All right, guys, we spent a lot of time talking about sequences. We're now going to dive into our last topic of the year. We'll spend a couple days kind of going over it, but I want to talk about series. So how we've used the title of this kind of unit as sequences and series. We know what a sequence is. A sequence, right, is just a bunch of numbers in a row in a certain order, right? It's basically a list of items in a certain order as we defined it officially. So what is a series? Well, series is very closely related to sequences. It actually uses sequences. A series, okay, what is a series? It is the summation of a sequence. So a series is basically adding together all the numbers or a partial set of the numbers, okay? So in many cases, rather than writing out a few terms to give the pattern, you'll usually be given the series in something called summation notation. And I'll show you what that means in a second. Okay, or it's also called sigma notation now. That is a Greek letter. Greek letters are scary. I'll try to make it less scary for you. So if you see something in sigma or summation notation, just know that it's math speak or math language for find the sum of that sequence. So one of the things you might see, and you can see it kind of down below here, right, is if you see this symbol right here, that's sigma. It's a sigma notation. It's the Greek letter sigma, okay? So usually in sigma, you're going to have, right here, I'll put explicit, oops, formula. So kind of right in the middle, you're going to see the explicit formula. So I'm just kind of breaking down, like, what is it you're going to see and what are each parts mean. That's going to be the explicit formula is going to go there. At the bottom, you might see something like n equals 1. Sometimes you'll see I equals 1. That just tells you the term to start with. So if you see I equals 1 or n equals 1, it really doesn't matter what the letter is. If the number is 1, it means term to start with. So we're going to be starting summing up the sequence with the first term, right? And then at the top, usually you're going to see another number. In this case, I'll denote n. That's the last term to sum up. Okay, so let's just do something real quick here. I've never done this. I'm making this up. Let's say we have a sequence 2, 4, 6, 8, 10, 12, 14. And I gave you sigma notation. Okay, and I said I equals 2. And then I put 5 here. I'm just going to say we don't have a formula for this sequence. Normally we would. Normally you'd put the formula in right in there, but we'll just put sequence in there for now. What is that asking me to do in that sequence above? It's saying sum up this sequence from the second term all the way up to the fifth term. Okay, so we're going to be summing up, okay, the second through the fifth. So it would be 4 plus, I'm just going to write it down below. That would be 4 plus 6 plus 8 plus 10. And if my math's good, what's that? 10, 28. Right, so that whole thing here would be equal to 28. Sum up the second term to the fifth term of that sequence. That's all it's asking you to do. So don't try to get too crazy with things. All right, so let's take a look at an example here. So it says, sigma notation from n this time, 1 to 5 of 3n. Don't forget 3n is your explicit formula, and I'm summing up the first 5 terms from 1 through 5. So what this is really asking me to do is to sum up the first 5 terms. Well, how would you get the first term? You just plug in 1 for n, right? So that's the first term. And then I'm going to add to it the second term. That's the second term, plus the third term, plus the fourth term, plus the fifth term, okay? And then we add all those together, you get 45. All right, so don't let the sigma notation confuse you. It's really pretty simple. Again, that 3n here, right, is the explicit formula. All right, if you feel good about this, try the second one. Hit pause. Try sigma k equals 1 and 6 of 1 plus k squared, and see if you can give me the answer. I will run through it too in a second, but if you want to hit pause, give yourself a shot. That might not be a bad idea. All right, so hopefully you've hit play now and have got an answer. So I'm going to do the first 6 terms. 1 plus 1 squared, plus 1 plus 2 squared, plus 1 plus 3 squared, plus 1 plus 4 squared, plus 1 plus 5 squared, plus 1 plus 6 squared. If you add all of those together, you get 139. Okay, you get 139. So you might be saying, okay, well, Mr. Bodner, I get what you're doing, but this is going to take me forever, especially if I have to do a lot of terms in the sequence, right? So if we look at the one above, this was an arithmetic sequence, if you remember. Arithmetic, and this turned out to be geometric, right? This would be 4, that would be, no, actually, no, sorry, it's not geometric. Take it back, it's neither. But either the case, right? Imagine we had to sum up a lot of terms in the sequence, right? That would be a lot to do, right? That would be a lot to do. So sorry, that's not 2, that's 4. Let's take a look and maybe we can shorten this a little bit. So some ways to sum up sequences. So now that we know what it means in math language, right? What are some ways, quick ways, that we can sum up certain types of sequences quicker? So I have this problem here. Sum up the first 10 terms of the function 3n. Now you might recognize that 3n is an arithmetic sequence. We talked about last week about ways to recognize from the equation what's an arithmetic sequence, what's a geometric sequence, and if you weren't quite sure, you could do the first few terms of this sequence and realize that it's an arithmetic sequence. Okay, so what you could do, right, is you could do 3 times, you can do 3 times 1 plus 3 times 2 plus 3 times 3 dot 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 all the way up to 3 times 10. Okay, and get 165, which would be the correct answer. But that would take you a while to write it all out, multiply all the terms, sum them all up together. There's got to be a quicker way, right? So there actually is a little quicker formula we can use. And the formula is pretty simple. Okay, so to find the sum of the arithmetic, so I just want to highlight, this is not any series, only arithmetic series. To sum them up, it's n over 2, and n just represent the number of terms, right? Number of terms we're summing up. Number of terms summing up. So in the problem above, we're summing up 10 terms, so that would be the n. Okay. Times, so n over 2 times a sub 1, which is the first term, plus a sub n, which is the last term. So let me write that out. Last term. A sub 1, we should know what that means. First term. So it does involve you actually doing 2 calculations, at least in terms of this sequence, calculating the first term in the sequence and calculating the last term. But with an explicit sequence, that's pretty simple. You just plug in the place you're trying to find. So if we actually do this out, let's actually do this out. So n is 10. We said 10 over 2 times, what's the first term? The first term is 3. The last term, which is this guy up here, 3 times 10 is 30. That would be 3 plus 30 is 33 times 10 over 2, which is 5. So 33 times 5, guess what? 165. Okay, so it makes it a really much simpler problem if we can do that way. All right, so example here. Find the 150th partial sum. What that means is just find the first 150, the sum of the first 150 sequences. 150 terms, sorry, not 150 sequences. Find the 150 partial sum for the sequence 5, 16, 27, 38, 49. Begin first by writing out an expression using sigma notation, then solve. Well, before we can even write the sigma notation, we need the explicit formula to put in the sigma notation. So we have to calculate the sigma notation. So if I'm looking at this, the first thing I should be thinking about is, all right, is this arithmetic? Well, it needs to be, because that's the only one we know right now, or geometric. It's arithmetic, and it looks like the D value is 11. And if you're not sure, you can subtract the two numbers from each other. The D number is 11. And then my formula would be A sub n. If you remember, your arithmetic basic formula is 5, which I'm going to use the first term, plus n minus 1. And again, why it was 1 is because I used 5, and 5 is the first term, times the D value, which is 11. Again, I'm getting this from one of the first days we did arithmetic sequences and the general formula we used. If you're a little bit shaky on it, please go back and check that. All right, we're going to simplify this. A sub n equals 5 plus 11n minus 11, or A sub n equals 11n minus 6. So what's this problem asking me for? It's saying find the sum of this sequence from 1 to 150 of the arithmetic sequence 11n minus 6. Well, now that we know the shortcut, we know it's n over 2, which is 150 over 2, times the first term, which if I plug in 1 for n, I get 5. And then if I plug in 150, you'll realize the last term of the sequence is 1644, so obviously you'll need your calculator. But all you need to do is 5 plus 1644 times 150 divided by 2, or 75, and you'll realize you get 123,675. Okay? So the formula itself's not really that hard, you just kind of have to know it, and since we're doing remote learning and everything's open notes, you don't even have to memorize it. Fairly simple in that sense. Okay? Just remind yourself again of how to find the explicit formula. Right? The explicit formula, you need to use that in your sigma notation, so it's really imperative that you can calculate that. So if you are still feeling kind of shaky, make sure you ask questions in class next time about that, because that's going to be really important. Okay. All right. So I want to get now into geometric sequences. Okay. Geometric. We can do this one pretty quickly now that we kind of know what we're talking about with sigma notation. So I have a geometric equation here. Again, sometimes people use n for the variable, sometimes people use I. Don't let that confuse you. I is just a variable. So what this is saying, okay, is sum up the first 5 terms of this geometric sequence, 3 times 2 to the I minus 1. And if you remember your geometric sequences, this value right here, the 2, is your R value. R is 2. So it's really asking me to do 3 times 2 to the 1 minus 1, plus 3 times 2 to the 2 minus 1, plus 3 times 2 to the 3 minus 1, plus 3 times 2 to the 4 minus 1, plus 3 times 2 to the 5 minus 1. So there are the first 5 terms. You'll see that this is 3, this is 6, this is, 12, 24, 48. Okay? Plus, 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 plus. And you'll realize that all comes out to 93. Again, not horrible doing it that way, but kind of a pain. Open yourself up to a lot of chance for error. Also, if there are more terms than the first 5, this could take you a while. So there must be a shortcut for a geometric series as well, and it is. My formula, okay, for this, the sum of a geometric series, is just simply the formula a sub 1, the first term, times, and in parentheses, be careful, 1 minus r to the n. Again, n is how many terms you're summing up, which in this case is 5, and r is that 2 value in this case. So 1 minus r to the n divided by 1 minus r. okay? That will also give you the geometric summation or the geometric series. So in this problem, what is the first term? So you have to calculate that. It's 3. And we're going to multiply it times 1 minus 2 to the 5 over 1 minus 2. Okay, so just be careful here. I'm going to do this out a little bit slower. You should get minus 31 in the numerator, minus 1 in the denominator. That's 3 times 31 over 1, or 31, which is equal to 93. Okay, which is the same thing we got above. Just be very careful on your calculator. You're doing things in the correct order. You have parentheses where you have them. I would highly, highly encourage you to try to do this formula on your calculator. Now that we know that this answer is 93, see if you can do that on the calculator and get 93. There's nothing worse than getting to the assessment on Friday and doing everything right, but then you can't do it on the calculator, right? Because part of the problem is getting the setup correctly, but if you can't give me the answer, that's going to hurt you. So make sure you can do it on the calculator. All right, so let's do a couple here, and then it'll be time to go. So it says, for the following two series below, find the sum. You'll need to first determine whether it's geometric or arithmetic. Okay, those are the only two options here. It looks like the first one is my geometric one. Okay, so a couple things maybe to think about before you jump right into the formula is that r is equal to 1/2. Okay, and then maybe to find the first term, a sub 1 equals 1/2 to the 1 minus 1, or 1/2 to the 0, which is equal to 1. So my formula would be a sub 1, which is 1, times 1 minus 1/2 to the 8th, okay, over 1 minus 1/2. Again, highly encourage you to do it in the calculator with me. You should get an answer of 255 over 256. Okay, you can leave that as a decimal if you'd like. Okay, I don't know if that comes out to a decimal, but it does come out to 255 over 256. So make sure that you get the same answer I did there. Last one, I encourage you to hit pause, give it a shot yourself, determine if it's arithmetic or geometric, and if it is, come up with the summation of the series. And then you can do it along with me after. All right, so it's definitely arithmetic. We should know that. We need the first term and the last term. So a sub 1 is going to be equal to -1. A sub 7 is equal to -25. So if I use my formula, n over 2, 7 over 2, times the first term plus the last term, that's going to give me -91. Same thing here, practice on the calculator, guys. There's going to be nothing worse than not being able to get it on the calculator when you have all the correct work written down. All right, so your homework, okay, for tonight will just be, let me take a look. We've got that. All right, so let's do 1 through 10. So homework, okay, numbers 1 through 10 on worksheet number 9.